There you have it, ladies and gentlemen, to all of our mad hackers out there who's currently watching right now. It's 5:26 in the afternoon, and we're down to our last segment for today's first ever virtual hackathon in Mindanao. And we're down to our not so near yet so far, but this is one of the most exciting segment that all of you guys and of course Hakbang team has been waiting for. We will be talking about artificial intelligence. So together with us is the technical manager of NETZON, Hil Regalado, and joining with us, of course, is the CEO of NETZON, running this company in the Philippines. Please join me in, Charisse. Yeah. Hi, ma'am.
Hey, Jerome. Thank you for that introduction. Hi, Hil. I'm not the main speaker, but I will just give you an overview of our company. And then, and then Hil will follow suit and talk about the topic that you're most waiting for. So let me just share my screen.
Yeah, go ahead.
Yeah. Oh, I'm still not allowed to share my screen yet.
All right, hold on.
Yeah. All right.
Our director to let you be one of
I promise you I won't take long. I talk fast anyway, so I won't take up much of Hil's time.
I think you might need to go back to the backstage so that the
I'll leave.
director, can ask you can assign you to be one of the co-hosts
All
so
right.
that you can share screen. So
I'll be
ayan.
back.
All right, we'll wait for Cherise. So I know you guys are very much excited for this topic from the title alone, artificial intelligence. So if there is an artificial intelligence, really don't have an idea what that is, but we have two good people out here who will be sharing with us what's really this artificial intelligence. This might be one of the possible solution to the current problems we're facing right now due to this pandemic. Maybe the artificial intelligence could be one of the medium or the catalyst to speed up the resolution of the current problem. So they will be talking more all of that. I guess our Charisse is up and we'll try to wait for more. And of course, sa lahat po ng mga nanonood dyan, we are also streaming live at our YouTube channel. That's Hakbang TV. And Charisse is here. Go ahead,
Yeah.
Charisse.
All right. So I'll be quick. I just want to introduce you to our company. It's called NETZON. And our purpose and our mission is really to create a positive impact through the use of technology. We have two offices. Our main office for marketing is in Sweden, and the operations is here in the Philippines. And this is our team. Lacking one core value, but these are the four core values that we strongly follow. As you can see, we really have fun. Sometimes people think we're not doing anything, but if they only know how serious the things we're doing are, but it's really part of who we are as a company. And so these are some of the technologies that we specialize in, and we do web applications, mobile, we do data visualizations, analytics, and as you know, what will be our topic for today would be AI and machine language. So sharing with you our tools, I think some of the hackathon participants can see some familiar tools here that we're using, Slack. So these are the tools that we use, and just sharing with you some of the projects that we have had and that are still ongoing. So we specialize in retail. This is an online platform. And if you want to know more about this product that I'm showing, you can just go online at their URL. So this was, I think, one of the things that I discussed in our previous live interview, the healthcare solution. This is our client and this is their product. You can also go here to see what they have in store for healthcare. So this is one of the other things that we've done. So if you can see, it's really healthcare and retail mostly. Psoriasis app, and this is something that you might be interested in. So we're doing IoT in terms of Bluetooth mesh, and that's another one we're going to be talking about next week on Monday. So I hope you can join us there too. and just a few of our other clients. And that's it for an introduction of NETZON. And I'm very excited to introduce our main speaker for today. He is one of the people that I most admire in the team. He is a digital adventurer. He prefers to stay indoors with his loved ones, and he loves everything that flies in the air or moves underwater, or even those that go around in space. In his spare time, he follows geopolitics, foreign policy, and anything state-of-the-art military. He knows about that. So you can also ask him about that. But today, he will be talking about artificial intelligence and machine language. Please help me welcome Hill.
Thank you so much, Charisse, for joining with us. We were so shocked that you're with us right now, but it is an honor and pleasure to have you on board. Thank you so much. And right now, I guess he's ready, ladies and gentlemen, mga kamad hackers. Please help me welcome the technical manager of NETZON to show us what really an artificial intelligence is, Hill Regalado.
Hi, thanks for the introduction, Jerome. Okay, so I'll be sharing my screen in this video so that you can see my presentation. Okay. So I'll start with this slide that indicates a Dilbert. This is actually a Dilbert comics. And there is this guy who wants to introduce a product as an MVP. And the other guy notices it's just a block of wood. And then the first guy introduces, this is AI, artificial intelligence. Ask it any question. So the other guy asks, what is my middle name? And the first guy says, it's being shy, just like people. So the other guy, dumbfoundedly, just says, it has emotions. So basically, AI, this talk will be about AI, and I hope this talk will contribute to your knowledge of AI. But full disclaimer, at least at this moment, I am not an expert of AI, but I can share to you what we've learned working with AI with NETZON. So at least our experiences and some of the basics that we've been able to learn. Okay, so this car should be familiar by now by a lot of us. So this is the Tesla, and then a product of Tesla. And it is one of those cars where there's a feature called autopilot. And also, everyone should be familiar by now, some of these icons. I'm not going to say these words as it might trigger all these AIs in your phones, in your pockets. But all of you who use AI on a daily basis might be familiar with these words. So this is just a video I'm going to play about how it works in a car like Tesla. So for some of you here who has a car like this one, then you might be using this every day to go to the office, do some groceries. Others might be interested in buying one. So I'll play this video now. It's just for a few seconds so that at least you can see how it works. So this video is in fast forward, and the driver's hands are off. So this means the car is driving by itself, and it's assisted by satellite navigation in the center console, and it guides the car where to go. And it should be safe so that at least a lot of people will buy the car, and it is. But of course, this is a developing technology, and they are improving it day by day. So just an inside look of what happens from the inside of the car. So I'm going to play this clip once again, and this is one of the cameras in the car. And of course, the car has many sensors, cameras that look out to the outside and see what's out there. And AI is continuously working behind the scenes so that the control surfaces of the car can be controlled. So applying pressure on the accelerator, applying on the brake, and just enough so that the person sitting, the passengers of this car, will not be injured. So it should be a safe travel for the passengers of the car. you can experience sometimes if there's someone studying for the first time how to drive a car. It might be a bit the experience might not be too good. So in this case, the AI that drives the car is now, at least at this moment, well trained, and the experience will be quite good. Another example here I'm going to show is a couple of things going on. Um, there will be some AI and machine learning lingo thrown around here and there, but I'll try to explain them as we go along. So this is one of Detector. It is a research and development effort by Facebook. And what's its purpose is to identify stuff in an image. So partly you could say this is an image analysis tool. And then what it's doing here is a job called segmentation, where portions of an image, pixels, a group of pixels, are grouped into one area and then identified. So in the upper left corner, it is being labeled as a sky. In the right corner, it's a tree. And the persons are also labeled. There are also percentages being shown. Those are the confidence levels of the AI that was trying to predict what this bundle of pixels are. So this has identification and segmentation going on. And so there's a new term here, deep learning. I will go deep into that later, but first, these are some of the applications. We have image recognition, NLP, natural language processing. NLP is quite common right now. All Android phones have this. All iPhones have this. That being Siri and Google Assistant. Also, today we have Alexa and Cortana from Microsoft. Might not be common in some areas, but in other areas of the world, they are more ubiquitous. So a lot of people will use them on a daily basis. And so all this, for example, the portfolio management and prediction, drug discovery, and better diagnostics of disease in healthcare, speech recognition, and self-driving cars are some of the applications for AI. So this is another comic I'm inserting. I'm really a good fan of Dilbert. So here's the manager asking for a schedule, and then the phone rang before the secretary did. Confirm that the secretary was able to note that down. So never mind, my phone took care of it. So sometimes, at some point, this will be more common, and I think this is happening today already. And this is just an example of how some tasks might be replaced by AI in the future, whereas someone has to spend for front desk, especially those are some of the tasks that are at risk, but can be replaced at some point by AI. And this is just one example of that. But I don't think it's here now, but it's something that everyone can prepare for. And if you feel like you're one of those that could be at risk, then at least we have good time to prepare. Especially in these challenging times, it's really a good idea to look at some areas that so that we can prepare for eventualities. Okay, so I'm just going to be discussing some terms. So we have a couple of abstractions that we can check out so that we know exactly how deep this goes. So AI is just like another science subject, could be taught in school someday at an earlier age, maybe added like science, math, history, and maybe at some point AI. And then also beneath that is a more specific topic of machine learning. And there are dozens of different ML methods. And also lower that, we have another subject, neural nets. So this is the neural network area. And then the way to teach these neural networks, there are a couple of techniques, and one of them is deep learning. So these are different things. They are being described as different layers in the technology stack, or at least as subject matters. But there are three main components here. One is the data set, another is the algorithm, and then the features. I'm showing here some notes on the data set. There are a lot of public data sets, and I will open this link so that at least you'll be familiar how that might look like. So here's an example of a public data set. Okay, I hope you can see that. And then here listed in this site are data sets for agriculture, biology, climate and weather, physics. Example, if I open the biology data set, the American got, I'm not really an expert in biology or anything, but we have stuff like this. So this contains a lot of data regarding this particular topic of biology. And there are a few more data sets. One interesting way others have been working with AI and producing data set is using synthetics. Basically, instead of collecting information, they produce the information where AI can be applied to assist in training the machine. So this is just an example of a production of human faces where the AI can learn from, instead of actually having someone to collect thousands of pictures of faces. And this is now the application. But they're saying here, Microsoft Research, it's being trained not with real human data, but with synthetic data. Okay. Next is the algorithm. There are many ways algorithm is being used. So we have here Detector 2, BERT, and Transformer. So Detector 2, a work of Facebook I showed you earlier. Some of these algorithms are best applied for different use cases. And there are way more algorithms than I'm linking here. And then we have features. So in the Detector 2, for example, I showed some features where it was detecting the face, the trees, the objects, or even the road. So these are some of the features that we're trying to, in case of Detector 2, classify. So basically, it revolves around this area, the dataset, algorithm, and the features. A very simplified block diagram would be something like this. But what's happening here is that we have some training examples that we use to train the model or the machine learning algorithm. And these examples, what we do is we use that to teach the ML. And then once we have finished teaching, we have determined that we can now test. We try it with inputs, and then it produces outputs. For the technical guys, here are some of the tools that are being used as described by this snapshot from an NVIDIA training module. TensorFlow, CAF, Keras, MXNet, PyTorch are just examples of the tools that are used. And then you can export the neural net, which was used during which was trained as the output of the training. And then finally, you can optimize that and then deploy it. So the deployment can be quite varied depending on the application of the AI. So for example, in an application like the Tesla, of course, you're going to deploy the AI, everything about it within the car. So that at least if you are cut off from the internet, the car can still drive you around. That's just an example. Or have a good way to at least hand over back the control of the car to the driver. So this really depends on where you deploy your AI solution. I'm also adding here darknet, which is I'm really a fan of. So they have, I think, a newer version, but here we have the YOLO v3. I can show later how this works. So that's also one of the tools. So basically, this is how roughly a neural network might look like. It's actually patterned from a little bit of our biology, especially in our brain where there are neurons. But there is an input layer and an output layer. The input layer could be the pixels in an image, and the output layer could be pixels in an image, or also um, coordinates or regions of that image. And some others, the output could be just plain classifications of what that image could be. If you give it a picture of a cat, then on the other side, it will show up as a binary representation of what it means if there is a cat in that picture. So that's just it, the input layer and the output layer. And what we're really trying to achieve here is to have a good amount of hidden layers, with each layer, with each node in the hidden layers having different weights and biases, and then such that the final output is what we desire. So there's a quote here from Weights and Biases, one of the tools that most machine learning professionals use in training neural networks. The number of layers is highly dependent on the problem and the architecture of your neural network. You're essentially trying to Goldilocks your way into perfect neural network architecture. So this statement means trying to Goldilocks your way into a perfect neural network architecture is that it's partly you're somewhat like guessing and trying to tweak it a little bit, tweak it more until it works good. So that is one way of doing AI, and this is how they would describe it. And then we have two different things. As I said earlier, in the abstractions, there was machine learning, and then beneath that, there was deep learning. So basically, what the difference is that with machine learning, you're actually helping out the machine to learn. So if you want an artificial intelligence that can say to you, if you give it an input of a picture, it can say to you whether it's a cat or not. Then you'd have to have so many pictures of cats. And then number one, you'd have to be sure that the positive input are actually pictures of cat. And then you put all those pictures of cats to the machine learning, so that once finally, if you use that AI, then it can say to you, if you give it one picture of a cat, then based on the training that it has done with all the pictures of the cat that you have taught this neural network, it can say that now I am seeing a cat. So that's just an example. So with machine learning, with the traditional way they do it is you'd have to have the phase of feature extraction where you teach it, these are all the pictures of a cat. Deep learning is different, and it is done in many ways, but a layman's description would be that you give it tons of input. Typically, this is done if the input is so many, or the file size when they are digitally recorded is so huge that it would be difficult for humans to assist with the classification. And also, if the input is very complicated. So what happens is that they would just give out all these inputs to the neural network, and then the neural network would try to do feature extraction and classification by itself. And then finally, if you're going to use it later, the neural network would be able to have its own interpretation of the classifications. So a good example, I think, about this is if you give someone bills, a couple of peso bills, for example, 100, 500, 200, 1,000. Even if someone doesn't know how exactly what the value is for each bill, I think a regular human would be able to uh, create a stack of bills with similar denominations. So someone can pretty easily put all the 100s together, the 200s together, the 500 and the thousands together. So it's like that guy, you didn't have to teach him that this 1,000 peso bill this is its value. The guy can just by looking at the different shapes, the different colors of the bills, they can pretty easily segregate that or classify each bill. So that's just an example. But pretty much, this is a slide that Thor Guipo has in one of his learning modules in YouTube that I really like. Uh, Earlier, I showed to you uh, about Tesla that drives cars. That AI is specialized to driving cars. And this, for example, a human being should be able to change a diaper, plan an invasion, butcher a hog, con a ship, design a building, write a sonnet, balance accounts, build a wall, set a bond, comfort the dying, take orders, give orders, cooperate, act alone, solve equations, analyze a new problem, pitch manure, program a computer, cook a tasty meal, fight efficiently, and die gallantly. And he says in the end, Robert A. Henlin says in the end, specialization is for insects. Not all of us might be able to do all this, but I'm pretty sure all of us can do a lot of things. So this is the kind of AI other people are rooting for. An AI that is super generalized. It can do one task and then do another. So this is basically how one should compare AI to a human being. And then just a brief summary of what I have discussed so far. So under machine learning, then there is the supervised, semi-supervised, reinforcement, and unsupervised. Uh, Basically, this is more apparent when I showed you the slide on the machine learning where the AI is really being taught. And then the other one, which you just give them a lot of input, and then the AI will learn by itself. So supervised is the example on the extreme left, and then the unsupervised is an example on the extreme right. So there are semi-supervised and also reinforcement learning. This is another slide. It's not from a link here. I've linked in the presentation. The supervised learning are basically good for regression and classification. So if you want to teach an AI pictures of cats, of course, you'd have to give it all the pictures of cats that you know of, so that it later on, once it is shown a picture of a cat in the future that is not part of your library, it can at least say that's a cat with a certain amount of confidence. That's classification. And also there are regression. So basically statistical regression, if you give it a lot of data, it can try to predict where the data set will go through. Then we have unsupervised learning. Mostly this is done with clustering and association. The example I gave earlier where a human can easily segregate the denominations. If you give them a bundle of bills, Philippine peso bills, a human being can easily segregate the hundreds from the 200s and the 500s. This is the same thing. And this is being used all the time by many different companies in our everyday lives. I'm quite sure a lot of us are registered with Netflix. Netflix this all the time. So if you watch certain videos, they record that, and then later on they recommend what kind of video you might want to watch later. So those kinds of applications to a business actually ensures that the video they're offering is always, at least with their recommender system, closely associated to what you're watching before. They will have more views. YouTube also does this and a lot more. So that's just an example. Then the last one is reinforcement learning. And this is when there is an agent, and then you put that particular agent, or let's say in simpler terms, you are a guy and you're dropped in an island. And then, of course, you'd be in this example, you're alone in that island, you're just immediately dropped there. Of course, you'll have to figure things out yourself. Let's say it's very far from civilization, that island, and then you have nothing else. Then you have to figure your way out, to either your way out, or at least for the time being survive on that island. You have to look for things that will help you survive in a daily basis. That's exactly what others do with reinforcement learning. So what they do is they have this agent, they put in an environment, and then they let the AI try to survive in that environment. One example is uh, what they call this AlphaGo, but I will discuss that later. So just another comic brief. So this guy is asking, this is your machine learning system, and another guy on top of a mound of so many mathematical stuff, he says, yep, you pour the data into these big piles of linear algebra, then collect the answers on the other side. And the other guy says, what if the answers are wrong? Just stir the pile until they start looking right. So basically, I think that's one of the good summaries so far of what I've discussed. So these are just random algebra, basic math, but of course it's more complicated. But that people try to pile up and add more inputs, more data, and then stir it a bit until the output it's producing looks right. So this is from XKCD, which is a good comic that you can follow also. So this is a story. This is a picture of a book. The Royal Games, I think, is the title. One of the stories in this book was for a doctor, where the doctor was in prison during, I think it was during World War II, and at the prisoners camp, this doctor had nothing to do. So what the doctor did is that he read all the books there until he found out, no, until he found out that I've read all the books and it's getting too boring in this place. And then he decided maybe he will play chess. So this doctor tried to play chess, but he has no one to play with. Then he decided, why not play with myself? He then later tried to split his brain into two parts. One is player A and the other player B. And then each part of his brain would play against the other. So this is now the doctor being one guy, mentally split his brain so that they can play against each other. And then at some point, this doctor, once he was free from the prisoners camp, would later meet someone else who was a master of chess. They play the game, and it turns out this doctor who had played by himself defeated the world chess champion. So this is an example of how one might simulate working with reinforcement learning or AI. So this actually happened just a few years ago, 2017. So AlphaZero was an AI modeled a bit similar to that fiction story I told about earlier. So this AlphaZero played by itself. The one that would win would later on do a match with itself again. And then another algorithm, Stockfish, was a good chess program that was one of the best chess programs before AI entered the scene. But Stockfish, being a program that was really developed only for chess and had no way to learn by itself, was later on defeated by AlphaZero. So here's a note of AlphaZero on Wikipedia. That's a very interesting story, and this one is by DeepMind. You can follow along on YouTube. They have very good content about teaching machine learning, AI in general. Also, I'm linking here a learning resource from Kaggle. They have if you want to learn machine learning yourself, it's a very interesting resource, and they have competitions also where you can try if you're improving in this field. So it's for those who are interested, then please visit this site. But that's not the end of the story, though. There are pre-trained models for those out there who would like to try out AI without having to invest in the teaching or training stage. Not all of us have huge amounts of data for a certain domain. Like if you want to train cats, then not everyone can produce a lot of pictures of cats. So if you want to train a cat detector, for example. So there are already existing materials for that, data sets, and there are also pre-trained models. So one of those that have a huge collection is Tensorflow. Tensorflow is another tool for AI development that is, I think, sponsored by Google, and they have quite a lot of pre-trained models. These, when we say pre-trained models, these are the networks, saved networks that were previously saved on a large data set. And by large, some of these are really large scale. And I doubt any one person would be able to collect by his own in some cases. Then, so these big companies have already done some of the groundwork on some of them. Also, some of these pre-trained models are owned by public domain and others by universities. So for applications of AI, NETZON specifically, we are more inclined towards edge AI, where we have the models trained already or from a supplier of these models, and then we integrate them with a whole suite of other systems, and then implement this on the edge. So an example is attendance, facial recognition, crowd monitoring and control, QA, advertising, customer experience, image analysis, and chatbots. All this and more while being isolated from the internet. So we've already downloaded everything, the neural network, the saved model, and saved them to an example, this chip that we use for some of the clients.
I didn't understand that.
Okay, let me turn off Bixby. Okay, so this chip, for example, is one from NVIDIA. It's a good chip that handles AI workload really well. But these projects are quite interesting. This comic, for example, shows another case where a guy is asking whether the app should check whether they're in a national park. Then the girl here says, sure, easy. Give me a few hours. And then the guy said, and check whether the photo is of a bird. And then that changes everything. Now you need to be able to detect that if there was a bird in there. Then I'll need a research team and 5 years. Hopefully that will not always be the case today. So this is another scenario where a requirement can feel like it's easy to do. You just need an app that detects whether there is a bird or not, but it actually takes a lot of time. NETZON can be your partner in leveraging AI for your business. So we do R&D, technology integration, most especially with on-edge applications, where edge meaning there being no internet where you want to apply AI. And then we also do deployment, maintenance, and support, and training of staff or those that engage with this technology. Here's another clip. Customers are complaining about our home speaker product with AI assistant. The other guy said, it keeps learning family secrets and blackmailing its owner to buy upgraded parts. So this is another Dilbert comic, and I really like this because this shows the kinds of stuff that might happen if we abuse AI. So as an end note, I recommend for those who are interested of following through. There are some links here for responsible AI, and Microsoft, Google, and Accenture also have links here. Not all countries have the opportunity to where legislature has been prepared to deal with breakthrough technology like AI. I also think it will take some time before we have regulation on how far AI can be applied. And so this is actually just another slide, I think, which is a really worst case scenario if someone really implements AI really badly. So to end, just a quick demo for those who are following along. There are links here. I intentionally put them in bit.ly. So if you're interested, you can just type it on your browser and then click on copy to drive and then run all. So I'll just do this, try and do this, and so that you'll at least see how it works. But you don't have to follow along if you don't have your laptop ready. Let me open the link. Okay. So this is the YOLO example. So what you're just going to do is you're just going to copy the drive. And then after copying that, you will now have your own copy of this project. This is actually Colab, Google Colab. It's a product that allows you to run Python. And what's interesting is that if you click on run all, they will let you borrow a machine in their data center, and then you can run commands on this machine. And then, as you can see, it's initializing, and now it's connected. It's letting me borrow a virtual machine that has a GPU in it. And a machine that has a GPU in it is quite a good example of where people can run AI. If that finishes the execution, you should be able to see now it's in this stage of the execution. This is, for example, in my case, I'm using this as input. I'm a fan of Big Bang Theory. I hope yours as well. And then it applies the YOLO neural network against it. And then the final output is a picture of how the AI understood the input image here. The next one is the next example is the Detector. This actually takes too long to run, but what you can, I have prepared the executed, I have executed this beforehand prior to this meeting, and same input, and then this is how the AI would understand it. So it is doing segmentation, this example. So now it knows that this bundle of pixels are a person, another person here. So it at least saw all of the people here. So if you have an application that where you need to count the number of people, just like YOLO, this is a good example of that. And then it is also able to detect this green area is a dining table, and there are bottles on it, and then of course the handbags and everything else. And then another area is the some call this pose estimation. So once it detects that there are people here, it tries to estimate how the position of these people relative to the rest of the image. So at least with this, if you need to check their position, for example, if their bodies how they are angled, every segment of their body, then this is one way to do it. And this is part of this example. And then this is another segmentation that is applied to the rest of the image. So it now knows that there is a rug at the bottom of the picture. And but it know at least it tries to detect those stuff. It knows quite a bit. Also, the last one is we fed it with this video. Uh, then this video is actually coming from YouTube. If you want to try this out, then you just change this part. You find a YouTube video, and then you change this part. And then what we got is at the end of is that you can download the result of this analysis, and then we can then apply the analysis for the entire video. So you can see here it's labeling what it sees in the video. And for the last one that I'll show you, this is one of our nodes that we can deploy. Let me close this one. So this is actually one of those chips that we have. It's running on just in a small box, and then we feed it a video, and in real time, in this case, it's trying to check if there are cars in the live feed. But in this case, this is actually just saved in the device for now, because we couldn't connect it to the network at the moment. But if you can try out this link, then you can open this up. Unfortunately, if you try this out, I lose the labels on my end. So these are the cars that are passing through. And there are also quite a few features where you can add lines of interest. And then if this particular car goes through those lines of interest, then it it can count how many cars cross there. So this is just a few of the applications that NETZON has tried out, and if you have similar problems, then we can work with you with those problems and can be your partner in delivering solutions to solve those. And that's basically it. If you have any questions, maybe Jerome can, if there are any participants who need who have some questions, then maybe we can help with that.
Wow, thank you so much, Hale. That was really an awesome presentation. I know some of our viewers out there, especially the IT guys, would really, would really think that this is really gonna be a big step for them. So the links that you've shown earlier, maybe our viewers are interested in checking on that. We will be putting the description of that link on our comment section so that you guys as well could really identify and really play around what AI is, because I firmly believe that artificial intelligence, or commonly known as AI, is rapidly an advancing technology made possible by internet that may soon really have significant impacts in our daily lives. This will bring immense socio-economic opportunities while also providing solutions to the ethical and socio-economical challenges that we are facing right now. So if you guys wanted to know more about this, please visit NETZON. they can create a better version of life through technology. Am I right, Hale?
Yep. Thank you.
Oh,
I agree.
that's fine. And you're agreeing with that. Why I know that slogan, right? So I, of course, I do searching so that we can really promote what NETZON is. So of course, within the coming days, mga mad hackers, we will be joining with a lot more from NETZON. They will be teaching us what's the latest technology, the latest trends in technology we can use. You can also use in your products, in your businesses that would make your life much more easier. So with that, we would like to thank NETZON and of course, Ma'am Charisse for joining with us this afternoon. Thank you so much. We'll be back for more announcements.
Thank you.